Hello there, Algebras. Welcome to your Chapter 2, Lesson 3 notes on dot plots with deviations. And so what we're going to talk about today is the symbol for standard deviation and what a deviation from the mean is actually referencing. And how we're going to do that is we're actually going to look at some dot plots that are going to show us 3 different brands of batteries: brand A, brand B, and brand C. And we're going to use that data to compare what is going on in the different types of batteries. We'll use what's then our standard deviation, or a deviation from our middle, our mean value, in order to compare what we're looking at in different types of battery lives. Okay, let's start with battery brand A versus battery brand B. So here are 2 dot plots. Each plot on the number line is one set of battery hour lives. Okay, that's what's going on here. So if you notice, for brand A, there are 1, 2, 3, 4, 5, 6 batteries that we tested. And for brand B, there were 1, 2, 3, 4, 5, 6, 7, 8 battery lives that we tested. Okay. Do the battery lives tend to differ more from battery to battery in brand A or brand B? Okay, well, look at brand A. Kind of just look at the range in brand A. You're from here to here, right? The lowest battery life to the highest battery life in brand A. And look at brand B. The lowest and the highest. We've got a big difference there. So, yeah, they tend to differ more in brand B. The battery lives differ more. And you can see that the range is very obviously larger in brand B. The range is obviously bigger. Think carefully on this one. Would you prefer to buy battery brand A or B based on these 2 dot plots? It's always the big question I ask my classes. And I can always tell who are my conservative ones and who are my gamblers. And I go with, and this is a me personally, I'm going with brand A. Because brand A is a little more reliable. I'm not a gambler. I prefer the reliable. And I know I'm going to get at least 80 hours of life out of battery brand A. Battery brand B, I'm risking less than that, way less than that, right? Or way above. And that's why I know I got my gamblers out there who are like, come on, I could get over 120 hours out of one battery in brand B. I'd go with that. Not me. Not me, personally. There are some of you that would, but boy, oh boy, I like the old reliable. Now what we're going to do is we're actually going to know what these dots are. So I know that this number line isn't like perfect. And we're going to know their actual values. We're going to use those actual values to find the average, the mean in each of these battery lives. And then we're going to use that to then add and subtract with our actual data values. And I'll show you what that means. That was a lot of instruction all at once. So let's just scooch this up and show you our 2 tables. Okay? So we got battery brand A and we got battery brand B. All right. In battery brand A, let's plug in these actual values into L1 in our graphing calculator. So grab your graphing calculator. Here's mine. And press Stat Enter to get into L1, and let's type these battery lives in hours into L1. And so I'm getting all these into L1. It's a pretty good data for brand A. I need to find the mean in brand A, so the average. So now I press Stat, I arrow right to Calc, and I do 1 var stats, with list 1. Okay, there it is. Pops right up as my very first thing. Brand A's mean is 101 hours of battery life. Now I need to do the same for brand B. Okay, so I press stat and enter, but now arrow right over to list 2 because we're going to want to come back to battery brand A at some point if we want the data to stay. So in list 2, let's put our battery brand B life. And look at that, 73 and 76, way low. Then you got 92, 94, 110. Ooh, so we kind of like do a little bit of a jump here. We got a couple here that are real nice and high as far as battery life, all the way up to a 123. Holy smokes. And there are more batteries that we tested there, so maybe there was more possibility for that. I don't know. But let's get the mean, the average, for this data set. So press stat, arrow right to calc, and we want to do one var stats again, but this time we want to do one var stats on L2. So notice where your highlight is, press second and 2, and that changes our list to L2 that we're going to run our data set on. So we calculate, ooh, that's a lower mean. 100.375. Interesting. Okay. Well, now what I'm asked to do is take each data value and subtract the average from each data value. Okay, subtract the mean from each data value. So let's see. I've got 83 in battery brand A, which means I'm subtracting my mean from battery brand A, 101, from that. Okay, I get negative 18. Now I do that again, so it's 94 minus 101, okay, negative 7. 96 minus 101, okay, negative 5. Ooh, wait, this one's going to be above my mean. So when I subtract, 106 minus 101 is a positive 5. Okay, 113 minus 101. So again, I'm on the positive side. So look at this. We've got deviations below the mean, and we've got deviations above the mean. Deviation just means a difference. Where are we above it? Where are we below it? Okay? So we do see that our mean is right here. Our 101 is right here. And the stuff below it is a minus deviation, a negative from that value. And the stuff above it is a positive deviation, a positive from that value. They're higher than that value. Well, now let's do the same with battery brand B, but let's just use 100.4. Okay, so let's actually use the value 100.4 as our mean. So it'll be a little bit easier to fit that in here. So 73 minus 100.4 is negative 27.4. Right off the bat, we already have one deviation from the mean that is way bigger than this deviation from the mean up here. So we can see that we had more of a range of our data in battery brand B right away. But you know what? If we had a low one like that, don't you think we probably have a high one like that too? Let's look. Let's keep going. So 76 minus 100.4, negative 24.4. 92 minus 100.4, negative 8. Okay, so we're getting closer to where the mean is, negative 8.4. So now let's try 94 minus 100.4. Notice I'm always subtracting data value minus average. Data value minus average. So my data value here is 110 minus 100.4. Now all of a sudden I'm above the mean. So I'm at positive 9.6. And so now I've got 117 minus 100.4. Now I'll be at 16 positive 16.6. Okay, 118, I'm sure you can guess what this one is, but again, I'm being just very clear and methodical about every data value minus the mean. That's how I get my deviations. So plus 17.6, and of course, a big one, so 123 minus 100.4 gives me a big whopping 22.6 as a deviation from the mean. So that much bigger than the mean. And the mean was right here between these two. Okay? So notice I'm showing you in this part down here how to get the standard deviation value from your graphing calculator. Spoiler alert, you've already been seeing it, we just haven't pointed it out yet. Because when you do one var stats, the SX is our standard deviation. What happens? Well, the graphing calculator has this wonderful ability to take all the deviations from the mean for each of our data sets, and it gives us what we would consider a normal distance from the mean, okay? And that normal distance from the mean gives me a range that most of my data will fall in. In fact, 68% of that data will fall between one standard deviation on each side of the mean. Now, like I said, we already have this spot that this has come out of. So if we press stat and arrow right to calc and do one var stats, now the last time we did one var stats, remember we changed it to L2. So I'm gonna run brand B's data standard deviation first. So just because I already have L2 in there, I don't want to change it back just yet. There it is, SX on my graphing calculator. Now this value is going to come out to be a rational, a non-repeating, non-terminating decimal. So you're going to have a bunch of decimal values behind it. What I'm going to do down here where I have some blank space, and we're going to recopy this on the next page where it asks for it, but I'm just going to write SX here for brand B in red. It's going to be 19.44176285. We will only round this value when we are told to by me. Round this value to the nearest tenth right now. So this will be approximately 19.4 for brand B's standard deviation, okay? And you know what I'll do, so we know this is approximate. I'll make my equal signs a little curvy. That means approximate. It's not exact. Now let's do that same thing with brand A. So we're going to do the same thing with brand A. So now I take stat, arrow right to calc, and one var stats on my graphing calculator, and I'm going to change my list to L1, back to L1. So second and 1 gets this to be L1. And now when I run this standard deviation, it's 12.13260071. And again, I'll have you round this standard deviation to approximately 12.1. Whose standard deviation was bigger, brand A or brand B? Whose range was bigger, brand A or brand B? Whose deviations from the mean were bigger, brand A or brand B? That's how it comes together. The range of your data is giving you the spread of your data. What is your data covering from where to where? And when the spread is bigger, the deviations from the middle will be bigger. The difference from the middle will be bigger when your spread is bigger. Okay? So what I'm going to do right now is I'm putting this page off to the side. I know you're in a booklet, but at the bottom of this page where I show you each graphing calculator screen and what to press, just like I've shown you on here. So this is just telling you how to do that when you're on your own, I do have my graphing calculator screens that I just showed you for brand A and brand B. This wants me to recopy brand A's stuff, which I still have on my paper right here. So I'm just copying it from here. You can just copy me since you're following along. 101 and 12.1 is what I'd like you to write down. And you can see those values here and here on the graphing calculator screen. Okay? What this is the arrow down showing you the range. Okay, that's showing you the range of brand A. This was all brand A. And now here I'm asking you to calculate that same thing for brand B, which we already know because we had already done those calculations. Okay, so I just give you all those screens in here so that you can see exactly what I'm referencing. And I give you the typed out words that I'm saying so you can do this on your own at any point. So this is brand B, which was 100.375 as its mean. And we did round to the nearest tenth, so this is going to be 19.4 as its standard deviation. I did tell you could round to the nearest tenth, so I did. Okay? So what we're going to do is we're going to take those two dot plots from earlier, and we put them back right here. So I just recopied those two dot plots. And what I'm going to do now is I'm actually going to add and subtract with my means for each of these brands. And I'm going to figure out where is 68% of the data going to be between. Okay, so let's start with brand A. Brand A's mean was 101. Well, let's add the 12.1 standard deviation and get 113.1. So brand A, I had written in blue. So what I'm going to do is right here, brand A, I took 101 plus my standard deviation to get 113.1. And now I'm going to take 101 minus my standard deviation to get, press second and enter to get the last thing you put in here, and then arrow to the left and change this plus sign to a minus sign. 88.9. Let's put those, let's find approximately where those are. So approximately 88.9. Okay, so there's minus 1 standard deviation for brand A. All the way up to 113. 113 is right about here. 113.1, that's plus 1 standard deviation. And we know that 101 is our mean. Look, how many data values do you count for brand A between 1 standard deviation above and 1 standard deviation below? 1, 2, 3, 4 out of 6. So this has 4 of 6 data values are within 1 standard deviation of the mean. Let's calculate that same thing for brand B. So brand B, your mean, we used 100.4. So let's do that again. Let's take 100.4 plus 19.4 and see where we end up. And then let's take 100.4 minus 19.4 and see where we end up. You're probably already thinking, well, we're going to end up with lower and higher numbers. And you're absolutely right, because your standard deviation is so much bigger. You are going to end up with most of your values spread out between a larger max and min of standard deviation spot. So let's try that again. I'm going to press second and enter to get the last thing I typed into my graphing calculator back. Then I arrow left and highlight on my plus sign and change it to a minus sign. And that just saves me a second, right? It doesn't save me that much time, but it does get me to 81 as my low end for my standard deviation. And notice that high and low are significantly above and below what brand A's high and low for around the mean was. So I'm going to go all the way down to 81 down here for my minus SX on brand B. Brand B's mean was right approximately here at 100. Okay, 100.4, so just a tiny, tiny bit above. And then, of course, it goes all the way up to 19.8 as plus a standard deviation right here. So look, we have 1, 2, 3, 4, 5 out of 8 data values within one standard deviation above and below the mean for brand B. And that's the answers to questions 7 and 8. Brand A is 4 out of 6, which of course, when we divide it out and get a percent, is 66.6%. And when we take brand B's 5 divided by 8 and find that as a percent, that's 62.5%. Both right about 68% of the data. That's usually where it is about 68% of the data. Now, we're talking about typically bigger data sets. These were very small data sets so that we had the time to plug into our graphing calculator and analyze. But now knowing what you do and knowing like how many things are falling where they are, look physically at where these are on the dot plots. Now which brand are you gamblers going to buy? You could still be gamblers, right? That was the initial thought process. I could still get a high one out of this one. So you might still be going brand B. I just got confirmed to myself that I want reliability and I'm still going with brand A. I got that confirmed, okay? That I've got a smaller range of potential battery life and I want to be able to plan on a battery life when I'm purchasing batteries. I want to be able to plan on this is reliably going to be at least 85 hours of battery life, right? Okay, so I'm going to throw one more battery brand into the mix, and that would be battery brand C. And I am actually comparing battery brand C to only battery brand A. Now, to be fair on this comparison, like I was saying before, it is less batteries that I'm looking at for this one. Okay, so battery brand A, still the exact same ones that we had before. So battery brand A, still going to be a mean of 101 and a standard deviation of 12.1. Okay, but now we look at brand C, and you probably noticed something right away about brand C. Where is it? All of brand C is above 3 out of 6 of the brand A battery lives. And battery brand C, here's the minimum, here's the maximum. The range of data is smaller. So let's predict if the standard deviation will be higher or lower than brand A. Yeah, I'd say higher. Oh, excuse me, I'd say lower. My bad. I'd say lower. I'd say we're going to get a better standard deviation is what I was thinking in my head. I'm going to get a better standard deviation. It's going to be closer to my actual middle data value than these standard deviations were for brand A and brand B. So, also, let's kind of consider, what do we think the average for brand C is going to be? Because I think the average, if there's these 1, 2, 3, 4, 5 of them, the average is going to be over in here, right? Right around 110, 109, 111, somewhere right over here. Well, we got the data down here on the table. Let's figure it out. So this table is what I'm going to use, and I'm going to press Stat, Enter, and arrow all the way over to L3 to put in my data values for brand C. And I noticed right away that the data values I'm entering for brand C are so much higher as a general rule than the battery brands A and B. So when I run stat, arrow right to calc, and 1 var stats, let's change this to L3, so second and 3, okay, and calculate. Oh, I was almost right on the money, right? My mean is 110, so that is my average, and I'll write it on here as well. 110 hours of battery life. And my standard deviation, I'm going to write the whole thing out, and then I'm going to round to the nearest tenth. So always write the whole thing out and round if you are asked to. You are being asked to by me, so we are going to do that. So let's round to 8.2 hours of battery life. And as predicted, a lower standard deviation. We're still going to take this 110 and subtract it from all these data values to see each deviation. So 115 minus, I did that right. Data value, 115 minus 110. Always data value minus mean. That's a positive 5 because we're above. 119 minus 110. 112 minus 110. So all these were above the mean. 98 minus 110. And this is below the mean, so that's where that's going to be negative because we're down below. And of course 106 minus 110 and below. So if you notice, if you compare these, and I'm just going to pull up my other table just for 1 sec. Okay? When you've got a smaller range in your data, a smaller max minus min, your deviations by definition will be smaller and closer to your actual average. This was our middle of all the work that we did, right? This was a middle range. Notice my deviations are in the middle. This was the biggest range, so my deviations from the middle were the biggest. So the smaller the range, the smaller the deviation, or the distance away from your middle. That's just how this works, okay? So this brand C shows the least variability, and comparing these two, brand A shows a greater variability because it has a bigger range and a bigger standard deviation, okay? And we did already prove that brand C had the higher average out of the two of brand A and brand C. Has the highest average of the three, all right? And which would I expect to have the greater deviations from the mean? We already knew it was brand A because we ran the calculation on it. So I just wanted to make sure I plugged all that back in for you. When finding deviations from the mean, it is always the data value minus your mean, minus your average. Use stat, arrow right to calc, and 1 var stats on your data sets to find SX, to find your standard deviation. Always show me the full decimal value of the standard deviation. Do not round unless you are asked to. Never round unless you are asked to on standard deviation. Be very careful about that, okay? If your range is large, your standard deviation will be large. If your range is smaller, your standard deviation will be smaller. Okay. Go right ahead and practice this on our homework. We have some small data sets, again, to look at this with. Please use your graphing calculator to help you. Please ask me if you have any questions. And we will check out more deviations from the mean as we look at some more sets of data. Okay? Battery lives. This one's a good one. I like this one. I definitely get to find out who are my people who love the reliable and who are my people who love to gamble. All right, everyone. Thank you so much. You have a wonderful rest of your day, and I will see you for box plots.